Question 2, this one considerably easier than question 1. I think question 1 was the most difficult one to do. So a person throws a ball vertically downwards, striking the ground below with 200 joules of kinetic energy. The person then throws an identical ball vertically upward at the same initial speed from the same point. So what we're being told here then essentially is that the kinetic energy of the object when we throw it upwards is also 200 joules, right? Because kinetic energy equals half mass times velocity squared. So if the object's the same and it's thrown with the same velocity, then they hit the ground, then it also has 200 joules of energy. So what is the kinetic energy of the second ball when it hits the ground? So basically what we're being told is, if I can draw this, it's kind of a weird scenario. I don't really know why they're making it sound so complicated. The ball hits the ground with 200 joules of Ke, kinetic energy, right? Then it's not the same ball, but it's a ball that has the same mass, so it is essentially the same ball. Is thrown at the same speed, right? So if kinetic energy equals half mv squared, if it's the same object with the same mass and has the same velocity, but it has the same amount of kinetic energy. So this new scenario, the second ball is thrown upwards with Ke of 200 joules. Okay, move this over. So I'm going to get rid of this first scenario. We'll in fact, let's put this central. So we throw this object up with 200 joules of Ke, and at the bottom it has 0 joules of GPE. So we're going to use this idea of the mechanical energy of the system equals kinetic energy plus gravitational potential energy. Now this time we don't have to worry about, well, that's bad anyway. This time we don't have to worry about internal energy because in the question it says neglect friction or ignore friction, something like that. So we're not going to have any internal energy here. This is going to be true at all times. Mechanical energy will remain the same. So at the top, then, if we have 0 joules, at the top, we're going to have 0 joules of Ke because we're stopping at the top, and we're going to have 200 joules of GPE because all of this at the start became this at the top, right? And then it asked you for the kinetic energy as it hits the ground. So as we go back down, guess what? It turns back into this. So the answer will be 200 joules of kinetic energy when it hits the ground. Right? It converts all into GPE, and then it converts all back into kinetic energy. Yeah, using this idea. All right. The answer choice is 1, 200 joules.